All right, so let's get started. We're here for WIGM and why you want an operator, not just to preach about what they are, but really the value and why you want one. Like I said, my name's Carson Anderson. I work for Weave, not that Weave. You can come ask me about cluster networking, service mesh, GitOps, but that's a different company. My Weave is a small business toolkit with a focus on integrated communications. So totally different company. We're an end user. I'm on GitHub at Carsonoid. That's where the source code for every presentation I've ever done is on. And I'm on Twitter at Carson_ops. I'm going to start with a obligatory what is an operator slide. I'm going to put a lot of crap on the screen, and I'm not going to read any of it. Because this is the Google definition of what an operator is, and you can Google this yourself. Really, like really what an operator is a pattern. It is a pattern that we implement using Kubernetes tools typically, and the Kubernetes API and the Kubernetes features to run our systems in a more pleasant and efficient way. That's it. There's no language. There's no really prescribed toolkit. It's just a pattern, and you'll see what I mean when we build some operators later. So instead of preaching what an operator is, we're going to see why we want one by running something just above a hello world bit of software. It is not much more than a hello world, but it's more interesting. We're going to run this thing that I wrote, and we'll show you the code for this in a second, called WIGM, and it stands for Wasteful Individual GIF Mirror. It's exceedingly simple software that really is just bash on top of Nginx. And it does exactly what it sounds like. It goes out to the internet, we get a GIF, we pull it down, make a web page, and serve that web page up again. One GIF, one web page, one pod, one maybe load balancer per GIF. Because we're going to be doing a lot of these, right? We're going to be running a lot of different servers. We want to spin them up and down quickly. We want to operate on them efficiently. It should be easy to do all of these things that I've got on the screen. This is kind of this basic, if you look at this, it's just basic CRUD for your application. And as a bonus, I'm going to show you how you do this without any dedicated images, because building a Docker image for each GIF would be more wasteful than even I want to go. Every time we deploy WIGM, we're going to deploy it with a handful of configuration. We're going to give it a name. This has to be Kubernetes friendly, because it's going to go in Kubernetes places. We're going to give it a couple environment variables, a source link, because we're a mirror, so we go out and get some original GIF, a title that we put in our HTML, and then two business decisions for each deployment. Do we create a dedicated load balancer in the cloud for this GIF? Might not go wasteful. And do we make an ingress rule for this GIF or not? This is 5 configuration options. I don't think I've ever run anything in the real world that only has 5 configuration options, right? Like this is really simple. But you'll see how even with just a handful of things, some of the other tools break down, and operators give you a lot of visibility and a lot of power. And every time we do this, we'll get some things in Kubernetes. We're going to get a deployment for sure, a service for sure, maybe an ingress rule, again, depending on our business decision, maybe a dedicated load balancer in the cloud. And we should know, based on our inputs, what we've got and be able to read that easily. So let's start. It was inevitable. We're talking about GIFs. The project's called WIGM. It's always going to be Chief WIGM GIFs. And so we're going to do this with pure upstream Nginx, because you can. This is the software. This is the whole thing. It is bash on top of Nginx. We get curl. We download our upstream GIF. We make a web page with this really cool bashism called a here doc. That's way better than like 1,000 echoes. And then we serve it. Like this is the simplest software I could come up with that's better than a hello world. That's it. We're going to deploy the software a lot, and we're going to kind of compare all the tools that you might use when you go to run your software in Kubernetes. We're going to start with YAML, because all roads in Kubernetes start with YAML. That's just like it's a document declarative infrastructure. You have to declare documents, and we all choose YAML. We're going to move on to Helm briefly to see how just moving past YAML to literally anything else gets better. Then we're going to talk about operators in a couple forms. First, I'm going to talk about Metacontroller, which I did not write, but is a really cool way that you just write a webhook to build your operator instead of the whole infrastructure. Ignore the space. I'll come back to it. Then we're going to talk about the Operator-SDK and writing it in Go and what the power of running our application with that comes from. In the middle, by the way, I just learned about this thing called Kopf. And because, again, operators are a pattern, not a prescribed toolkit, if you want to get somewhere in usability and feature set between Metacontroller and the operator, which I'll show you how those work, Kopf is actually really cool. I just learned about it last night, so I didn't quite have time to write a new demo for it, but it's there, and it kind of fits in the middle of those two feature sets. Every time we use one of these systems, I'm going to evaluate them the same way. We're going to do basic CRUD. We're going to create a new instance. We're going to create a load balancer and not create ingress. We're going to update the title. We're going to re-enable ingress, just 2 different updates. Then we're going to report what we've done, and then delete everything. That's it. This is the basic rubric for testing. As I do this for each system, because we're going to do it 4 times, you're going to see this blue box move, and this just help keep track, hopefully, of where we are for each evaluation. So let's start with YAML, and this is your life with YAML. It is copy, paste, and type furiously, maybe a bunch of gross seds. Here's the WIGM deployment code infrastructure for YAML. What I've done, and a lot of people are tempted to do when you start using YAML, is I'm put all of my Kubernetes resources in one YAML file, so my deployments are easier. So I can just copy and paste one file to do a new WIGM release. I'm structuring my code for my operational concerns, which is really not a good pattern at all. I'm going to dig quickly into what the YAML is. It's basic boilerplate stuff. This is the most boilerplate Kubernetes deployment ever. All these things that are bolded would have to be found and replaced somehow if you release with YAML. So you might use sed or whatever to do a bunch of find and replaces. If we go further down in, again, 2 more find and replaces. We got to replace the title, we have to replace the link, and hope that these words don't appear in other places. This wouldn't work as it is, because title's in there twice if you didn't do the right kind of sed patterns. And then this is where I inline the entire WIGM software. That bash script, just multi-line, YAML, stick it in there, call it good. If we go further in, here's our service. It's pretty standard stuff. The one thing I'll point out is we've got our operational decision that we make by editing code. So if you want to change your mind about a release, edit this code and take a comment out. It's even worse with ingress. If we want to change our mind about making this ingress rule, we edit the source code and take a chunk of it out and say, oh, that's how we made our decision. It works, but it really falls apart quickly, and you'll see that in the demo. So let's do our quick evaluation of YAML. So we're going to do this. We would copy and paste. Again, we structured our code to make our deploys easy. So we copy and paste. We do a bunch of replaces. We uncomment one line. We delete another section. That's 3 different kinds of operations to do all these different decisions. It's already painful, and it's ugly and brittle. Our first update is not too bad. You could edit the YAML. The title's only in one place, so if you want to update the title, you just change it, and it'll probably work. If I wanted to re-enable ingress, I got to go find that code I deleted from the right point in time that I made this release, do all the find and replaces I should have done at that point, and then hope it works. And I don't even put it on here because you basically, if this is how you have to do a thing, you probably just won't. Reporting's okay, right? Again, I'm structuring my code for my process, which is not good, but it makes reporting easy. Although this is sort of a forest for the trees situation. You have a lot of data, not really relevant to my decisions, but just massive amounts of data. And deleting is fine, it works. So that's YAML. We all start there. It's a great way to prototype. It moves quickly, but it really, really breaks down doing the most basic CRUD on the simplest app I could think of with very few inputs. It already is terrible. So this is where people tend to move into Helm, and that's fine, right? You start to feel more confident. You're getting more power. You can restructure your code to be for your code's benefit, not your deployment benefit. This is what it might look like. I can now split out that YAML into multiple templates. I've got some chart metadata. I've got my release values files. I'm not going to go over this. There are a lot of Helm talks. The one thing I think is important here is when we move into Helm, away from YAML, we really start to put into code what our decisions are, what our inputs are, and we put them in Helm in this values file. And I'm going to bring this up specifically because you'll see it again when we come to operators, right? We now describe all our metadata for our inputs. And all those find and replaces are now templated information. This is great. Going further down in, this if statement in the middle is the cool part. No longer do we uncomment the section of code. We have an if statement for a decision, which is what a decision is. Same thing with ingress. That whole section, we don't have to worry about deleting it and replacing it. We just don't render it for a while. So let's do a quick evaluation of Helm. I know I'm breezing through these. I want to focus on operators. So in Helm, we would create a values file. And here I'm doing it again with the bash here doc because I'm a sysadmin by heart and I like bash. So we write this whole file. We use Helm install, give it the template directory and the values file, and it works. I'm going to focus on the bottom section here. This is kind of where things start to break down. It's kind of belies the complexity here at the bottom because we've got to have the Helm binary, we have to have all the values files, and we have to have all the template data. It's really, really hard with this system to integrate other things into rendering your Helm charts. It's not easy to create an integration for changing your decisions or deploying new things if you have to have this super specific constructed Helm environment. It does work, but it kind of breaks down. Our updates are much cleaner. I love this. You just change a file and do an upgrade. Again, you have to have a specific environment to have Helm work, but it's there. And the ingress, it almost doesn't look like I changed a file because it's the same process for ingress. It's not a thing we have to be afraid of anymore. It's just another change. Reporting is better. We have a little bit of metadata, but it's still too much data. It's not really telling me what I put into it. It's just telling me all the things, and I have to infer from this data what I really want. And deleting is fine. I have nothing to say about deleting in Helm. Except use the purge flag, or just always use the purge flag. I don't know why that's not default. So that's Helm, right? We've all done it. It's fine, but it's not great. It's not perfect. I don't have all the power. And for all the power, we use operators. And when you're using an operator, you just spam things out left and right. You have confidence, and you're just creating things like crazy, and it's always entertaining, and it's always amazing. This is where I come back to that values file. We've already kind of moved all our decisions into code, and to use an operator, we do this thing that you've probably heard a lot now, where we make a custom resource. We wrap that same, it's the exact same YAML. I'm just wrapping it in some Kubernetes metadata and saying, hey, this is the spec of a WIGM GIF now. And of course, in order to do this, you have to tell Kubernetes, OK, here's a custom resource definition. They're going to be called WIGM GIFs. This is the API and the version. One thing I will point out is this additional printer column section in the custom resource definition. Now I can tell it, hey, if someone uses kubecontrol get, here's the exact data that they'll probably want to see by default. You can get whatever you want out of it, technically, but this is nice to set some sane defaults for what you would see when you're reporting back, and you'll see that in a second. By the way, I know I haven't written an operator yet. We're going to talk about using one before we write them, because the point is, I don't care. I don't care how it's written. I really don't need to know the details. I need to know what my interface is and how to use it, and the implementation is someone else's problem. So we're starting with using one. So the principle of every operator, no matter the language, framework, whatever, is the same 3 steps: watch, seek, and report. We watch Kubernetes official things, and we watch our custom things. We get all the events as things change in the Kubernetes, with the Kubernetes API. We seek, do Kubernetes or whatever changes to get to that desired state and report on the transition to that state. And we do that over and over again. Every single operator, no matter what, follows this pattern. It's actually a really great pattern. So if I'm going to use an operator, this is all I really need. I don't really technically need this. You can do it with just your code. Again, we're back to YAML because all roads in Kubernetes start at YAML. And that's OK, because this YAML is just the right amount. So I'm OK with it. Let's do a quick evaluation. So our creation is create the WIGM GIF resource and then use kubecontrol or any API tool to create this resource. It seems as simple as Helm, but it's simpler because I don't need a specific environment. I don't have to have values files and templates. I really just need my inputs and a way to put them into the system and go. Edits are also really cool because we have all the same kind of capabilities, kind of like we had in Helm, but the left side has all these options now, right? We can do kubecontrol apply, edit, use the patch command, or any API patch to do these edits. And we'll do the patches in the demo with kubecontrol. Enabling ingress, again, you can't even tell I switched because it's the same thing. It's now, this thing that was terrifying in YAML is now as easy as anything else. This is where I think it gets really cool. The reporting now, we have the ability to get rid of all of the excessive details and get just what we want, right? I can look at this, and without knowing anything about the Kubernetes resources it made, I can see what the inputs are and where it is in that progress. I get the exact information I need without having to deduce anything from this wall of output. And I think this is a lot of value. You can get custom columns from kubecontrol or, again, any API tool. And deleting is great. Like API delete, kubecontrol delete, it's really clean. Let's do our demo. So on the top, I've got a cluster running locally with K3s. I love K3s. Recommend it to everybody who hasn't used it yet. And what I'm going to do is run a scripted demo, and we're going to use our operator. Again, not even talking about how we wrote it yet. So we write out this YAML file with a here doc, put it into the cluster, and all these things will suddenly exist. Boom. I can immediately look at this and see, OK, well, here are all my inputs. Here are what kind of service I made, whether or not ingress is created, what the title is, and whether the deployment is ready or not. And as we do upgrades, you'll see the deployment. If you watch these trues here in the middle, it'll change to false if it's ever not ready. So I get active information, just what I need. We go ahead and proxy in. You'll see WIGM work. There we go. Yay. The really, really simple software works. Big surprise. Let's go on and do our evaluation here. Got to Control-C that. OK, so we're going to do our update of the title. Again, I'm rewriting the file for the demo, but you could use any editor. Put in the cluster and watch that true change to false as the rollout goes. So it's false. It's not ready. We're in the middle of a rollout. Now it's true. It's done. Like, it wouldn't be that quick normally, but you get just that right information for you. We're going to enable ingress. I'm going to do it with a patch. I don't even have to have anything but literally the one field I want to change, and I can do a patch, and the operator is going to seek it. You'll see that ingress rule will pop up here in a second. Boom. I don't have to have all this structure. You can see how you could put that into a Slack bot for all I care. We're going to proxy in and see our changes. We should get our new title. I don't know. That didn't work. I don't care. You guys believe me. I don't have enough time to sit here and mess with it. We're going to do another release just because it's cool. You can see as we do multiple releases there at the top. It's going to be easier to consume lots and lots of these releases and get just the metadata. Like that first wall of text when we did our YAML demo was not too bad, but if you had 100 deployments and you have to deduce from 100, like this giant wall of text, all of your deployments and their decisions, it becomes really painful. Reporting, here's where we do our report. Deleting is really clean. I'm actually going to do one other quick thing that I think is really cool. I wrote this demo that just pulls random things from Giphy. Just to simulate, what if I just gave my users just access to start creating WIGM GIFs willy-nilly? If you did this with Helm or raw YAML, it would be really slow. You couldn't just write it in a tiny little bash loop, and it would be really, really hard to see everything and all the things that people are deploying. But here, I'm deploying literal random GIFs from Giphy, and it's really easy for me to tell whether or not people wanted ingress created or not, whether or not they, what their titles are, like whether things are ready. I can get just the information I need and nothing more. So we'll move on. Let's write an operator. That's what we're here for. You can kind of see the value. Hopefully I'm selling you on the business value and the operational value of moving to an operator. Now let's see how easy they really are to write, because it's not as hard as you think. So the first thing we're going to do is with Metacontroller. Metacontroller is a really great tool where you just write the webhook and it does the business logic for you. So we have our same chart from before, but the only thing we write in this chart is that little bit in the center where we create a webhook to do the calculation of the business logic. This is what it takes to run something with Metacontroller, omitting the fact that you have to install it ahead of time. You create a config. I'm running a deployment to actually run the webhook, and then there's the webhook code. This is the Metacontroller config. Ignore the spaces. There's a reason. What we're looking at here is saying, OK, we're going to have WIGM GIFs as the parent. It might make some deployment services and ingresses, and if any of those things change, call this webhook. That's all we're saying here. It's more verbose in detail because there's more options, but that's the core. We have a parent and 3 children. This is a kind of snippet of our web server function. Again, I'm writing it in Python. It could be any language. You just have a standard. You parse a certain hook with certain inputs, and you output what you want. So we take in the current state at the top. We say, here's the current state of the parent and the children. We calculate our desired state, and then we return from the webhook what we want based on the inputs or whatever we want. And Metacontroller does the work to make the output real. Because we're in Python, we now have some safety where we can do our cool string building. We have more flexibility, like Helm really breaks down if you do complex manipulations of objects, but Python can do that really efficiently. Our business decision is still in an if statement. We never lose that once we get out of YAML. And I know that's short. You can go look at the code and see the whole detail. It's a fully functional controller written in Python and Metacontroller. And it's better, right? It's a lot better now because now we can get all this value of the operator and really only write one function. And that's cool. The main thing that breaks down Metacontroller is at the end, we just say, here's what I want, and we hope that Metacontroller can do it. And if it can't, and it fails, we don't have any graceful points to really, any touch points to say, well, if that didn't work, don't do this. We just splat it at the cluster and hope it works, kind of like Helm. So to get the real power, you want to go to Golang and use the Operator-SDK, hopefully, because it takes away a lot of the horrible boilerplate of Operator-SDK, of Client Go. But we still have that same pattern. No matter what the controller is, no matter what you write it in, it's still watch, seek, and report. The difference is now we do all of these things, or rather we tell Metacontroller to generate, Operator-SDK to generate the code for all of these things. This is what it takes for the Operator-SDK to make a new operator. You say, make a new one, call it WIGM, and it boilerplates out a lot for you. If we dig in here, there's a lot of code in here. The one thing I want to point out is it's already generated all the YAML. Back to YAML. All roads start at YAML. We generate all the YAML to deploy our operator in the cluster immediately. You only have to make one change in here, and it's all usable. Now we say, OK, Operator-SDK, I want you to know that WIGM GIFs are a thing at this API, this version, and it boilerplates out first a CRD for us automatically, and also updates its role to say, oh, yeah, you should also have the ability to read these since we know about them. It also generates this types file, which is where I really, really get excited. Now we've got the same YAML we had in our values file and our custom resource, but explicitly typed in Go, right? This is, if you squint, it's still the GIF, the service, and the ingress with their different properties, but explicitly typed. So we know when we build this controller, if we're trying to treat things as types that they're not, it will not compile, and we have a lot more safety. Big advantage also of being in Go, if we wanted to say, for a WIGM GIF deployment, have people specify the CPU and memory requests and limits, I don't have to recreate that structure in my operator. I can pull in the upstream code and just embed the resource declaration and get all that type goodness from the upstream resources in Kubernetes right in my own resource, which is really, really great, especially that's actually a complex object right there. Now let's make our reconcile loop for our WIGM gifs. And we generate that with boilerplate generator here. And it would primarily make this WIGM GIF controller file. If we look in here, there's some pseudocode. This is what the controller does. I'm not going to bore you with the details. I just want to kind of show you what it does. It's what Metacontroller does. In fact, if you look at it, it says, watch the parent GIF and then the child deployment service and ingress, just like Metacontroller. We just write that code. And then it says, if any of those things change, sync the deployment, fail gracefully, sync the service, ingress, again, failing gracefully. This is what I want to point out. Now we're stepping through them, so we have to do those steps ourselves, but we get the value and the power of being able to back out or react intelligently to problems. We don't just have to splat at the cluster and hope it works. This is an example of what the deployment would look like if you were going to write a function. Again, the Go code starts to get a bit longer. That's kind of one of the downsides. But it's still, if you squint, it's still the same deployment that we had in YAML and Helm and in Python. It's just in Go strictly typed structure. We have all the kind of same values that we would get from Python, but now we don't have to like get nested map members. We can just drill down on types. We have strict type safety. One thing I want to say, if you look at this deployment object, it's scary. It's kind of terrifying. The first time you're in client Go and you try to write a Kubernetes official object in strictly typed structure, it's really, really ugly. And it's so ugly that I made a tool to do this for you. It's this thing called Structify. It's at structify.carsonori.net. And you can basically say, I've already got a YAML to define this thing I want to make. So I'm going to put that on the left, and I'm going to click the Structify button. And it's going to bring up and generate all the Go code I need for my object so that I can not have to generate this by hand, which is really, really, really painful. So I'm pretty proud of that. It works just on the latest Kubernetes version, but it works for all sorts of resources, and it tries even its best to give you the imports and make sure you point it at variables when you need to. So I'm proud of that. Hopefully, we'd like to get some feedback on it. Doing that by hand is just, it's the worst. The other thing, and the last thing I'll say about being in Client Go and having the Client Go operator is that we have a fully faked out Kubernetes client that they use for the official Kubernetes testing. So I have really, really good unit testing capabilities once I move into Client Go. Right? You can basically, there's a lot of code in here, but you make a fake client, you generate your object, run it through your same function that the real controller would use, and check the output. So you don't need integration tests. You can do unit tests to make sure your operator always behaves the exact way you expect every step of the way. So that's moving on to Client Go. Hopefully you're starting to see where a lot of the power comes from and the value. There's more work as you kind of move down that chain, but you get more and more reliability and efficiency and business value. This is my kind of opinion of where the things are and how they relate to each other. Just my personal opinion here. I really think that the only downside of using Client Go and the Operator-SDK is that it's got this learning curve, and I'm trying to hopefully help ease people away from that by having some tools like Structify and using the Operator-SDK to boilerplate out a lot of the work. But it's basically once you move, YAML's really only good for iterating and developing, if you ask me, and anything's better. That's it. So there's the link to the source code there at the top. I use K3S for all my demos again. I really, really love that. And if you like this, you should check out my, specifically my Kubernetes Deconstructed talk. It's been really, really well received by a lot of people, so I'm proud of that. And yeah, I got time for, do I have time for some questions? Yeah, 10 minutes. No. No, I didn't start the timer. Wow, okay, I went really fast.
So I'll run around. Who has questions?
Yep, okay. Is there anything anyone else wants me to recover since I talk so fast? I'm happy to go back. I'm happy to pull up more code. Oh, sorry.
Do you have any opinions on KubeBuilder versus Operator-SDK for doing Go?
I have not used KubeBuilder, to be 100% honest. There are things I'm learning every day. Like I said, I'd vaguely heard of COP, but I attended the session yesterday. So no strong opinions on either of those.
All right,
my strong opinions hopefully come across as, like, my strong opinion is use an operator. Like, you can immediately see the value that comes out of the operator pattern.
Sounds good, thank you.
No, absolutely not. No. The question was, does it have to be written in Go? No, that's, I know I pushed Go really hard, especially there at the end, like, because I really like it. But moving back to the, it's way back there. Let's move over to Metacontroller. So this is a really, really kind of abstracted away, a lot of the details are abstracted away, but Metacontroller lets you just write one single webhook sync function. And it could be in any language. Here it's in Python, but literally, like if you can write a webhook and say, I'm going to take in some JSON data, calculate what I want, and spit out some more JSON data to seek the new state, it can be any language. There's obviously, it came across really strong, but there is a lot of power in being in Go, but Conf, which I looked at yesterday, was really, really blew me away on how little boilerplate, and you can get a lot of these same benefits without needing to learn Go. And sort of like with everything, if you are comfortable and your team's comfortable with a specific language, I would recommend they use that, right? Like all things aside, like yes, I really love the Go stuff, but unless you really, really need like the bleeding edge performance and stuff that you get from Go, write in anything.
Hey, back here. You were talking about almost interchangeably about using the Operator-SDK and then client Go. Were you actually thinking of them as equivalent, or are you talking when you say client Go, you really mean the completely bare bones without the Operator-SDK, or are you thinking about them, separately or together? I wasn't clear on that.
You're right. I am mishmashing them together because Operator-SDK does use client Go under the hood, and you can kind of get access to the raw layers of that when you need to. There are other frameworks that don't use client Go and use their own stuff. So I use them interchangeably.
Okay. So quick follow up to that then is you are indicating that the testing capabilities of these two, which you consider equivalent, are sort of better than each increasing layer there. Mm-hmm. Okay, cool. Do you find that the client Go raw has even better testability than the Operator-SDK plugged in? Thank you.
So that's a trick because the Operator-SDK doesn't actually, I don't think, last I checked, doesn't have any like functions for helping you generate testing. It really relies on the fake client that I showed. Is the official client Go fake client. Like the Operator-SDK didn't rewrite it. It's really just there to take away the boilerplate of syncing. So yeah, I wish there was. I wish there was like an Operator-SDK, like nice, pretty way to write unit tests, but you have to kind of get in the weeds. Oh, yeah, okay, good.
Would you recommend running the operator at the namespace level or at the cluster level with cluster level privs or namespace specific privs?
That is a really good question, and I don't think there's a right answer to that. This is a fight that people have. I personally like having a cluster-level operator. I don't like the duplication and kind of the enhanced footprint of vulnerability, or not, but like things that could break by running one at every namespace. But you're right. Having a cluster-level one means that if something happens or it goes haywire or it gets compromised, then you have cluster-level access. But as far as I'm aware, the Operator-SDK is fairly opinionated, and it operates by default. Every operator that you build with the Operator-SDK, when you run it, by default it runs namespaced, but it has flags to go cluster-wide, which I basically use all the time. So that's a good question. Yeah? It does. So the question is, doesn't it have to be privileged? And yes, depending on what you're operating on. So there's a difference in running 6 different versions of the same operator in 6 different namespaces, scoped with their privilege scoped into that namespace, where if something goes wrong, then it can really only do things in a namespace, so you're kind of getting these blast radii.
Still do like KubeControl apply and things like that with custom resource definitions that are defined in namespace?
The custom resource, so the question is, do you have to do kubectl apply with the custom resource definition in each namespace? That thing is cluster-wide. Custom resource definitions have to be cluster-wide. The difference is whether or not the operator is looking at a single namespace or all of them. But you're right. If you're going to have a custom resource, it's either all or nothing. But you can then, just like pods are technically cluster-wide, you can give scoped access to pods to different things, by namespace or deeper. Anybody else? Yeah.
Do you have any particular strategy you'd like to use for how to apply the operators do they have a specific relationship with one application, or is there one kind of activity that you like to apply the operator for?
So the question is there like a specific relationship from operators to applications, or is there a specific way that I like to apply operators? I think there's a lot of use cases for them that don't fit the norm. So I've seen like two or three major use cases that I really like. One of them is really that you're actually seeing, I think Amazon was actually the first one to do this, where you make a custom resource in the cloud, and Amazon has written an operator that will spin up Amazon things for you, where you're using the Kubernetes API to manage Amazon things, and that's an operator, right? It's watching cluster state and syncing state somewhere else, but that's still an operator. The other one is kind of the one I showed here, which is more of the abstracting away applications, and you see this a lot with operators that make like different databases and that kind of stuff, where you just write a YAML and it spins up all your etcds for you. And you can obviously do that for your own things really, really easily. So I like that. I'm actually toying with, we make heavy use of Argo. I have in the last 2 jobs. I really like Argo CD. And the one thing that it's kind of short on is RBAC. The only way you do once you get SSO in Argo and you're logging in different users and groups, the only way to do RBAC is by writing to a config map and inserting a multi-line, comma-separated value bunch of RBAC data, which is really, really hard to do at any sort of scale. So kind of, to me, a third kind of operator, and I'm thinking about making this for Weave, is where you would take a custom resource and you say, this resource is RBAC permissions, and it just has whatever's going to be in that comma-separated values file as members. And the only thing it's going to do as you add and delete those custom resources is edit one field in one config map, right? It's sort of, instead of taking one thing and making a lot of things, it's the inverse pattern where I'm saying, well, this single config map entry with its multi-line strings is really brittle and hard to manage. So I'm going to say make a lot of custom resources and have an operator funnel those down into editing just one tiny thing in one place, which is, I think, an emerging third pattern. So.
More questions?
OK. Oh, yeah, please do.
Operator managers, have you been using that for them? And do you have any particular way any way you think they should be built?
Right. So the question is about operator managers and whether I'm using them or having any opinions on them. This is sort of like the operator of operators that the same team that's making the Operator-SDK is trying to work on. And I actually like that. It's kind of a nitpick on me that I can make this really cool operator and that I always have to have YAML to create it. It's actually a pain in the butt to get your operator into the cluster. I don't think there's a clear winner yet. I haven't used any that have really blown me out of the water, but I desperately see the need for one. I think it's just hard to, no one's really emerged with a good system yet. But if you've never used an operator, the idea is that somebody, and there are some out there, I just haven't had any personal experience with them, where there's an operator in your cluster that someone has to put in once in the cluster, and all your cluster users can make a custom resource saying, I want to run the WIGM controller or the WIGM operator in my namespace. And you just make a custom resource asking for that operator, and the operator of operators does whatever it has to do to make that resource, that operator run and work for you. So it's kind of like operators all the way down. And then you really only have to worry about how you get that first one in there, and the rest are as easy as using the operators themselves. So. Anybody else? I'm sorry I was speaking so fast. I didn't even get it under 35 ever at home. So made it really exciting. Thank you. Yeah, it's high energy here. I'm really caffeinated up. I appreciate everyone coming out, by the way. I know it's like the second to last talk of the conference, and everybody's like super hungover. And so thank you. Thank you, everybody, for coming.